Hello, my dear students. It is my pleasure to meet you again. I am Mr. Abdul Nasser Gaber and my colleagues in National TV. Hello again. We are going to now to study new lesson in geometry. We will start by similarity. What is the similarity between two polygons? If we have two polygons of the same number of sides, we will investigate if the two polygons are similar or not. So concentrate with me. If we have two polygons like that, one of them small and one of them big, and we will investigate if they are similar or not. If this polygon called AB, CD, and this one is called X, Y, Z, L. We have here measure angle A and measure angle X. A is the corresponding angle for X. If measure angle A equal measure angle X, measure angle Y equal measure angle B, measure angle Z equals measure angle C, and finally, of course, if we have three angles in the quad are equals to the corresponding three angles of the corresponding shape or quad, then the third angle, of course, it will be equal third angle, because the sum of measure of the quad here or here is 360 degrees. So, are these two quads are similar? Before we say yes or no, there are two conditions to be similar. First condition is if each two corresponding angles are equal in measure. This is the first condition. What is the corresponding angles? We said that measure angle X equal the its corresponding, which is A, measure angle Y equal measure angle B, measure angle C equal measure angle Z, and measure angle D equal measure angle L. So we have the first condition, which is each two corresponding angles are equal in measure. Is there any other conditions? Yes. It must be applicate the second condition, which is each two corresponding sides are proportional. What's the meaning of proportional? We knew that from our previous studying that if we have a ratio like that, 2/3 as example, it can be equal 4/6, and it is equal also maybe 2 times 5 equals 10 and 3 times 5 equals 15. So this ratio equals this ratio equals this ratio, so they are proportional. Okay, and if we talk about proportionality of each two corresponding sides, first we ask ourselves what corresponding sides here? XY, the side XY. What is the corresponding side in the second shape? Of course, intelligent students say AB. Why AB? Because X is corresponding to A, Y is corresponding to B, so the side XY, of course, will corresponding to AB. So XY and AB make one ratio, XY over AB. Okay, and YZ it's clear that it's corresponding to the side BC. So YZ over BC is another ratio. What about LZ? The side LZ will be corresponding to DC. It's clear to see that, because measure angle Z equal measure angle C, and measure angle L equal measure angle D. So LZ here in the first shape or first quad is corresponding to the side DC. So it makes the third ratio, which is LZ over DC. And the final one, XL, it's of course corresponding to the side AD. So XL over DA. So what is the meaning of each two corresponding sides are proportional? That means the ratio which contains each corresponding sides, like that, equals the ratio which contains the second two corresponding sides, equals the ratio which contains the third sides and the fourth. So for two shapes or two polygons, of course, of the same number of sides. Here we 1, 2, 3, 4 sides, and there 1, 2, 3, 4, or two quads. If the two quads here have the two conditions, each two corresponding angles are equal in measure, and each two corresponding sides are proportional, like that. Okay, something like it give as a number half, example, or 2 over 4, or any ratio. Okay, and we call this ratio K. So we are going to the next page. Make some revision about what we said today. We have two polygons, like that. If we have two polygons here, these two pages are two rectangles, and each two corresponding angles are equal in measure, and each two corresponding sides are proportional. So of course they are similar. Okay, let's move to another point about similarity. We will find a very easy method to write the similar quads. If we have this quad and this quad again, okay, A, B, C, D, X, Y, Z, L, and we know that these two polygons are similar because each two corresponding angles are equal in measure, and each two corresponding sides are proportional. We have to write these two quads in an easy method. We say that, another pen, polygon A, B, C, D is similar to, okay, this is the sign of similarity, the quad. Look carefully to A. A is corresponding to X, so we say A, we say X already. B is corresponding to Y, so we write Y. C is corresponding to Z, so write Z. D is corresponding to L, so it's L. And we have here quad A, B, C, D is similar to the quad X, Y, Z, L. And we will deduce something very important. To say the corresponding angles, if these two quads are similar, we say that measure angle A equals measure angle X. Also measure angle B equal to measure angle Y. Also measure angle C equals measure angle Z. And finally measure angle D equals measure angle L. So we have the first condition, if the two quads are similar, each two corresponding angles are equal in measure, even without showing the figure. This is the first condition. Second condition, we will look about the sides. AB over XY, concentrate with me to be easy for you. AB over XY equals BC over YZ equals CD over ZL. And finally, like an umbrella here, we say AD, the first and the last one, AD over the first and the last letter, XL. Okay. What we say about this? If we have AB of side length 2 centimeter as example, and XY is 4 centimeter, if AD equals say 3 centimeters, and this one XL equals 6 centimeters, DC equals 4 centimeter, and this is 8 centimeter. BC equals 3.5 centimeter, and YZ equals 7 centimeters. If we calculate AB over XY here, 2 over 4 equals half, and BC over YZ 3.5 over 7 equals half also, and CD over ZL 4 over 8 equals half also, and finally AD over XL equals 3 over 6, so it's half. And we call half by the symbol K. What is the K? K, we call it the similarity factor. Similarity, we can say similarity ratio or similarity factor. Okay, and K may be a number between 0 and 1 as half, or between or equals 0, all or greater than 0. So let's talk about this number K. We will concentrate about it now. If we have the ratios here, AB over XY equals BC over YZ, and so on, all of them equals K. K equals half. So K here is greater than 0 and smaller than 1. If K between 0 and 1, so if we have this squared and this one, if we say that this one M1 and this squared M2, and they are two similar quads, and K with is the scale of similarity or similarity factor or similarity ratio equal half. Half is between as example, half is between 0 and 1. So we say that M1 here is shrinking of M2. M1 is shrinking of M2, or reducing or minimizing. Okay, but if we have K greater than 0, greater than 1, sorry, greater than 0, sorry, again, greater than 1, that means that M1 here is enlargement of M2. So if K, which is the ratio of similarity, greater than 1, say 1.5 or 3 over 2 or 2.4, it's greater than 1. If K greater than 1, then M1 will be enlargement to M2. M1 here is enlargement to M2. Okay, and if K equals 1, then that M1 is congruent to M2 as two congruent sides, or two congruent triangles, or two congruent polygons as squares. Say if we have this square and this square, this is square and this square, and each one of them have side 1 centimeter, as example, 1 centimeter here. So the ratio 1 over 1 equals 1. So K equals 1. So the two squares here are congruent. Okay, so we have three conditions for K. The first one is if K between 0 and 1 as 1 over 3, 1 over 2, or 2 over 3, or so on, a number between 0 and 1. So M1 here will be shrinking or minimizing of M2. If K greater than 1 as 1.5, 3 over 2, 2.4, or whatever, M1 will be maximizing or enlargement of M2. If K here, if K equal 1, the two figures here, or the two polygons, are congruent. Okay, let's move to another point here. We have many polygons. It doesn't include in quads only, maybe polygons, pentagons, hexagons, or any two polygon. So what's the definition of polygon? Polygon is any quad, closed quad, or pentagon or hexagon has only 3 or more sides. As example here, we have triangles, we have quads, we have pentagons, we have hexagons, and so on. So all these are polygons. Let's look to an example here. Before the example, if we have 3 polygons, our 3 polygons can be similar? Yes, or more even. Even we have 4, 5, or so on. And if we have a triangle like that, and a triangle like that, and smaller one, and the triangle number 1 is similar to triangle number 3. Okay, and triangle number 2 also is similar to triangle number 3. So triangle number 1 is similar to triangle number 2. So if we have two polygons are similar to the third one, then the two polygons will be similar, or the 3 polygons will be similar also. We talk about the congruent sides of the congruent polygons. If we have here two congruent triangles, as example, triangle 1 and triangle 2, these two triangles are congruent, so of course triangle 1 is similar to triangle 2. But it is not necessary if we have two similar polygons to be congruent. Okay, that means that congruent leads to similar, but vice versa is no. Okay, let's move to an example here. Example number 1. Let's go directly to the example. If we have two polygons like that, this is the first one, the second one, this is A, B, C, D, X, Y, L, Z, and we have measure of angle A equal measure of angle X, measure of angle D equals measure angle of Z, and measure of angle L equals measure of angle C, and of course the fourth angle here will be equal to the fourth angle, because the sum of interior angles of measure of interior angles here equals 360 here and here. So the fourth angle equals the fourth angle, because the 3 angles here equal the 3 angles here. And we have as example 3 centimeter for XZ, 6 centimeter for AD, 4 centimeter for AB, and 2 centimeters for XY, 2.5 here for ZL, and 5 centimeters here for DC. Finally, 3 centimeter here and 1.5 here. So about the scale, don't worry about it, just look at the numbers. Are the following quads are similar? I ask you, investigate that. If we have here two quads with the same number of sides, and we have the first condition is measure angle A equals measure angle X, measure angle B equals measure angle Y, measure angle C equals measure angle L, measure angle D equals measure angle Z. So we have the first condition, which each two corresponding angles are equal in measure. Let's investigate about the second condition. What about the second condition? We will write these two quads here by the corresponding vertices. We say A, B, C, D, the quad A, B, C, D, and the other quad, we said A. The corresponding to A here is X, so write X. The corresponding of B, of course, will be Y. The corresponding of C will be L. the corresponding of D will be Z. Okay, and we will investigate about ratios. We say AB over XY equals what? AB here equals 4 centimeters and XY equals 2 centimeter, so equals 2 or 2 over 1. Let's go to the second one, BC over YL. BC here equals 3 and YL equal 1.5, so it's 2 also. The third ratio here, CD over LZ. CD is 3, CD is 5 over LZ, which is 2.5, and also equals 2. Finally, AD as umbrella, AD over XZ. AD over XZ, AD here is 6, XZ is 3, so it's 2. So we deduce that all these ratios are equal, so they will be proportional. So we have the first condition, each two corresponding angles are equal in measure. The second condition also, each two corresponding sides are proportional. Proportion means that all of them equal the same ratio here. So we can say that AB over XY equals BC over YL equals CD over LZ equals AD over XZ. So each two corresponding sides are proportional. So these two quads, of course, will be similar. Okay, my dear students, let us take a little break and we will return again. Okay. Hello again, my dear students. Let's complete our lesson today for similarity of two polygons. Example number 1. Okay, the second part, if we have a rectangle like that and other one like that, if we have two rectangles and we have 2 centimeters here, say AB, CD, XY, LZ, and 6 centimeter for DC, and here's 3 centimeters for LY, and 8 centimeters for ZL. We have here two rectangles, and it's clear that if we have rectangles, then each two corresponding angles are equal in measure, of course, because all of them are 90s. So measure angle X equal measure angle B, measure angle Z equal measure angle A, measure angle Y equal measure angle C, measure angle L equal measure angle D. So we have the first condition. Then what about the second condition? Try to write these two rectangles by the method we said, the rectangle ABCD, and the other rectangle, which is, look carefully for AB. AB is the long side, the length. So say XY, XY, LZ. Okay. Try to find AB over XY, AB over XY, of course, BC over YZ, CD over LZ, and finally AD over XZ. The question is, are these four ratios are equal? We know that each two corresponding sides, opposite sides in the rectangle, are equal in length. So BC, of course, 2 centimeters here, and BA equals 6 centimeter, because it's equal DC. XY equal 8 centimeter, and LY equal XZ equals 3 centimeter. So if we divide AB over XY, AB here equals 6 centimeter over XY equals 8. In simplest form, you can use calculator, or mentally you can divide here by 2 equals 3, and by 2 equals 4. So it's equals 3 over 4. Let's look BC over YZ. BC is 2 over LZ is 8. In simplest form will be 1 over 4. Okay, 3 over 4 doesn't equal 1 over 4. So the ratios here doesn't equal. So we can say AB over XY doesn't equal BC over YZ, and so on. So we say that these two figures are not similar. So the rectangle ABCD is not similar to the rectangle XYLZ, because it must be two conditions to move. We have here one condition, which is each corresponding angles are equal in measure, but the second condition doesn't satisfy. So we cannot say that the two rectangles here are similar. Let's talk about two squares. If we have two squares, one of them small like that, and the other is big like that, okay, and say that the square ABCD of side length 2 centimeters like that, and XYLZ is the big square, and each side equals 4 centimeters. We know that all angles here are 90s, they are right angles. So each two corresponding angles here are equal in measure, and each two corresponding sides, say AB over XY equal 2 over 4, which is half. BC over YL equal half also. So each two corresponding sides here equals the other one. For example, BC over YL, and so on. So the two squares here, of course, are similar. So we can say that each two congruent figures, or each two congruent polygons of the same number of sides as two pentagons, two regular pentagons, or two regular hexagons, or two regular octagons, all of them are similar because they are congruent. But as we said, congruency, it is not necessary to move to similarity. Congruent move to similar, but not vice versa. Okay, let's move to example number 2. Let's deal with the perimeter of two polygons. If we have here a pentagon like that, and another pentagon, this pentagon is A, B, C, D, E, X, Y, Z, L, M. These two pentagons are similar. We can say that the pentagon A, B, C, D is similar to the other pentagon, which is X, Y, Z, L, M. We know about a ratio, the properties of ratio. If we say that AB over xy. Because they are similar, it will be equal BC over YZ, of course, equal CD over YL ZL equal DE over LM, of course, equal AE over XM. Okay, we know that from the properties of ratio, if we add AB to BC to CD to DE to AE like that, let's add them. AB plus BC plus CD and so on, plus DE plus AE over XY plus YZ plus ZL and so on, LM plus XM. So of course the result will be the perimeter of the S1, we call this pentagon S1, over the perimeter of S2. So we can say that the ratio of the first ratio equals second equals third and so on, equal to the perimeter of first over the perimeter of second. It's very important rule here about similarity. We can call it similarity and perimeters. Similarity that we deduce that each ratio of these equal the perimeter of first one over the perimeter of second one. Okay, let's move to another example. If we have a quad like that, and another one like that, say that is D, A, B, C, and this one is Y, Z, L, X. We have two quads here, and we have C of measure 135 degrees, A is 70 degrees, and AD equals 3 centimeter length, and CB is 2.1 centimeter length. And here XY is 3 centimeter length. I apologize about the scale, it's not the same, it's just numbers. Okay, and this one is 1.4 centimeters, and ZL is 1.8 centimeter. Okay, and we said that the quad, it's given that the quad ABCD is similar to the quad XYZL. What is the request here? The request here is find K. Which is K? K is the similarity factor or similarity ratio. That's the first request. Second request is to find the measure of the angles and sides which they are unknown. Let's first put the sides and the angles. Measure angle here equal measure angle X. Where is A? A is 70 degrees. So measure angle X equals 70 also. The measure angle B equal measure angle Y. Where is B? B here, and Y here is 65, so it's 65. Okay. Measure angle C equals measure angle Z. C equals 135, and Z of course equal 135 also. Measure angle D equal measure angle L here, but we haven't the measure, so we can subtract the sum of these angles from 360. If we write 360 here, minus 65 plus 135 plus 70, so the answer will be 90. So angle L here equals 90, and its corresponding angle here D equal 90 also. So we have all the angles. And what about the sides and K? Let's move to AB over XY equals BC over YZ equals CD over ZL, and finally AD over XL. And let's substitute about the numbers. AB we don't know it. XY here is 3 centimeter. What about BC? BC here it is 2.1. YZ here 1.4 equals CD here we don't know it, and ZL 1.8. AD is 3, and XL is unknown. Okay, so we have K here. K equals 2.1 over 1.4. By using your calculator, you will find that the ratio here will be 3 over 2. So the similarity ratio, which is K, equals 3 over 2, which is any ratio of them. But we have the complete ratio here, 2.1 over 1.4. If we calculate it using calculator or mentally, it will be 3 over 2. What about AB? We know from the ratio AB equals, as cross multiplication here or scissor, AB equals 3 times 2.1, okay, over 1.4, and the answer will be 4.5 centimeters. And CD here also equals 2.1 times 1.8 divided by 1.4, and the answer of CD will be 2.7 centimeters. Finally, LX, to find LX of also, we multiply 3 by 1.4 divided by 2.1. Okay, the answer will be 2 centimeters. So now we have all angles and sides, all sides here, and we have AB, CD, LX, and we have K, which is the ratio, similarity ratio or similarity factor. Okay, let's move to another example. We will take an example about the pentagons. If we have two similar pentagons like that, first pentagon here and second one here, and the length of one of them is 3, 5, 3, 5, 6, 8, 10. don't mention it, don't concentrate about sides, because it's just numbers. And the perimeter of the second one is 48 centimeter. Okay, we can write the sides here: A, B, C, D, E, and here X, Y, Z, L, M, and we have the two pentagons here are similar, so the pentagon A, B, C, D, E is similar to the pentagon X, Y, Z, L, M, and the request is to find each side here. And he gave me the sides of the first one. Okay, first we will write, okay, we will write the sides here. We have AB over XY equals BC over YZ equals CD over ZL equals DE over LM. Finally, AE over XM. The perimeter of the first one, we say 3 plus 5 plus 6 plus 8 plus 10, okay, equals 32. And we have the perimeter of X, Y, Z, L, M equal 48. Okay, and we know that we can substitute by AB, move to AB, replace 3 instead of M, and remove BC and replace it by 5. CD, replace it by 6. DE, replace it by 8. And finally, AE, replace it by 10. Okay, so we have 3 over XY equal 5 over YZ equals 6 over ZL equals 8 over LM equals 10 over XM, finally equal 32 over 48, which is in simplest form 2 over 3. And making cross multiplication here to find X, Y, we multiply 3 by 3, divide by 2. Okay, XY equal 3 by 3 over 2, so it's 4.5. YZ equals 5 times 3 over 2 equals 7.5 centimeters. To find ZL also, 6 times 3 over 2 equal 9. And to find LM, 8 times 3 over 2 equal 12. And to find XM, as we said, 10 times 3 over 2 equals 15 centimeters. So now we have all sides. Okay, we have all sides of the second one, and it is given what? Given sides of the first and perimeter of the second, and we use this ratio, perimeter of first over perimeter of find, equal one of these ratios from the properties of the ratio that we studied before in third prep. Okay, let's move to another example. I know that similarity now is very easy for you, my dear students. Let's move directly to the following example. If we have two triangles, the first triangle XYZ is similar to triangle ABC, okay, and AB equals 4, BC equal 5, and AC equals 8. Find the length of sides of XYZ if the scale factor of the two similar equal, if we have the scale factor A equals 2.4. Okay, we say that if we have triangle XYZ is similar to triangle ABC, so we can say XY over AB, like that, equals YZ over BC equals the last side XZ over AC equals the ratio 2.4 over 1. Okay, and we have AB here equal 4, so we can say AXY equal 4 equals YZ over BC, which is 5, equals XZ over 8 equals 2.4 over 1. And we can use cross multiplication to find XY. XY here is 4 times 2.4, 4 here, times 2.4 over 1. So XY will be 2.8 centimeters, and YZ equals 5 times 2.4 over 1. It will be equal 3.5 centimeters. And finally, ZX equals 8 times 2.4, okay, over 1 equals 5.6 centimeters. Okay, and now we have all sides of the second triangle. Okay, we have finished now. My dear students, it's our end of our lesson for today. Next period, inshallah, we are going to study algebra, the new lesson of algebra. See you again. Be safe, stay home, go try to study well. Goodbye and good luck.